Hello and welcome. Thank you for checking out this video on the Berkeley Review books. My name is Todd Bennett. I'm the author of the General Chemistry and Organic Chemistry books, have been this since we started way back in 1992. Also a teacher for the chemistry and the physics classes. And in 1998 took over also primary author, editor of the physics books. And so I want to go over the books, but I also want to just let you know my perspective is coming from predominantly the chemistry books and the physics books. And philosophically, what we're trying to accomplish, and ultimately, in that sense, how you can get the most out of these books. And so, basically, what I hope to give you is just a little insight in how they're written, how previous students we've had who've done very well have scored. Been fortunate enough to have a top 1% score every single year I've taught, multiple 1% scores most years, and getting feedback from them, as well as the average student. Average student who's up around the 70th percentile gives a lot of feedback. And in tracking what they do, it really comes down to one simple thing: hard work at passages. And so I want to tell you how to do that, how to set up your schedule, how to take advantage of what these books offer. So basically, I'm going to give you the TBR on TBR. So if you will, the Todd Bennett rundown of the Berkeley Review. So I want to start with just the books themselves. How you get the most out of these books? It starts from passages. The biggest thing that sets our books apart from everything else on the market, the reason that students do better with our books than anything else, comes down to the fact that we have far more questions than anybody. Take the most questions in the second and third largest commercial available sources, combine these together, they still wouldn't match it. And that's how people do well. You learn from doing questions. And so I want to just toss a few ideas out there. The first one is that content review is the most overrated aspect of Mcat prep that anyone will do. And you see people make the mistake time and time again. I'm sure you've read stories on Reddit or Student Doctor Network, or you know somebody who maybe they got some general commercial book set that had nothing but just text in it. They went through these books, they watched a lot of con videos. They felt like they really knew their material. In fact, they might have even gone through some of the books twice or watched videos twice. They felt extremely confident. But the biggest mistake they made was they never took the time to actually do a lot of questions. They just read and theoretically learned about it. They had a lot of memorization down pat. They could regurgitate lots of different things, tell you about lots of facts. The MCAT did not reward them in any way. In fact, right now on Student Doctor Network, there is a story of somebody who did the same thing, studied a generic book set, watched videos to no end, studied, and I think they listed like 4 to 5 months, and they ended up getting a 492. The mistake they made, the mistake I implore you not to make, is neglecting to do questions. Learn content from questions. That's going to be, I guess, the big push. So, number of questions you have to do in just these books alone, just the ones that I've done, that's going to be a grand total of over 3,800 questions if you're doing just the chem and physics. If you also toss in the bio, the psych, soc, and the cars, you're going to be doing over 6,000 questions. Doing a question isn't just taking the question, isn't just doing a passage and going through the question and just looking if you got it right. It also is analyzing how you thought your way through it and reading the answer explanation, seeing if there's any nuances you could change or better way to answer a question. It's honing your craft. The MCAT gives you points for getting questions right on a multiple choice test. Your preparation is learning how to get as many of these questions right as you can. And so I want to talk about the whole learning curve for the MCAT. My favorite learning curve by far is one by Dunning and Kruger, psych experimentalist from the early 2000s, and they studied people as they learned material. And what they found is that most people at first have this overconfidence, this extreme notion that they know everything. And it leads to a false sense of security. And this is definitely what happens with MCAT review. Your basic review, your fundamental content review, is where the average student will start, and they think they know it. They look through it, sounds familiar, they've learned it before, they have this sense that I know this. And then when they do their first set of passages or apply it, like unfortunately if they don't do enough passages, first time they're really applying it, there's full-length exams, and they don't improve from those. They get a low score on those, they go and take the MCAT, they still get a low score. You have to build You can get your basic review down pat, but homework phase 1, we put a lot of emphasis in homework phase 1 being your content review, learning from your mistakes, reviewing material, just basically organizing everything you once knew and adding it to things you're learning, being ready for the content portion. So start with basic review, but if you study for, let's say, 500 hours total for the MCAT, no more than 10%, at most 50 hours, should be dedicated to content review, reading the books, doing flashcards, watching videos, any of those things that are passive processes where you're just looking at something and trying to remember it. Minimize that to no more than 10% of your time. Not saying that you don't need to have content down pat on the MCAT. It's just the best way to get it is not traditional methods of memorization, but application. Active learning always beats passive learning. So homework phase 1 will focus primarily on the information, the content. You'll build from there. Homework phase 2, you'll worry about timing. You'll have different styles of questions and passages. Although it's the same material from the chapter, it'll be asked a little bit differently. They'll be more time consuming. They'll be closer to real questions. And finally, homework phase 3 is the one where we are closest to the actual MCAT. A lot of experiments, a lot of interpretations of graphs, data analysis, things that are very common on the MCAT. Once you've finished all 3 homework phases, again, 6,000 plus questions, you're ready to start attacking full-length exams. Average student should take anywhere from 8 to 10 full-length exams. AAMC puts out the best of everybody. Nobody ever argues with this. You have to do all the AAMC, but for additional practice, I'm very proud of the exams we put out. They're going to be stylistically different than our homework. Again, they're a lot more, MCAT-esque, for lack of a better word. Go through these. Don't have to do all the exams, but if you can do 8 to 10, you'll be in a good position. Last few days, that's where you actually want to do content review. Ironically, it's at the very end, after you've already studied, know your content. It's not so much content review as content overview. Get the AAMC guide, get their list of what's on the MCAT, and literally sit there and one topic by one topic, inventory what you know. Inventory typical examples, typical types of questions they ask, how it integrates with other material. Let's say you're going through and talks about kidney. Well, kidney, you have to know, let's say, your ADH levels, your renin, angiotensin, those things that you studied, but also think about the fact that they could do a study on what an animal takes in through diet and then over a 10 to 20 minute period, what happens to their blood levels and what happens to their urine concentration, what happens to pH after somebody exercises. Know how it applies, know how you can integrate other material, because a lot of what they like to do is put biology into your chemistry, put chemistry into your physics. You have to learn how to mix things together. Okay, so how are you going to use our books to get to this point? Our books have 4 parts: reviewing, phase 1 of homework, phase 2 of homework, and phase 3 of homework. Each of these are designed in a specific way to build your knowledge up. The first part, the reviewing, I've taken a page out of the general chemistry book. You'll also find this in the OChem book, the physics books. It's just a rundown, tells you what you should be doing when you study through this. And you'll notice what's bolded right there: read only what you need. Cannot emphasize this enough. If you're spending time reading about things you already know, if you know Hardy-Weinberg really well, don't read about it. If you know Le Chatelier's principle really well, don't read about it. If you covered it in high school, in college, at least once, if not more, you don't need to read about it. Skim the review part when you know it well. Read in depth when it's something a little more intense. Let me just give you a sample of a page. This is the first page in the electrochemistry section. Electrochemistry might be one of those sections that you do want to read through, because traditionally, for whatever reason, college courses seem to shortchange this topic, in general chemistry at least. You see it again in OChem, you see it again in biochem. You get a thorough education in it, but oftentimes not just in one course, but across many different courses. And so I want to point out the way it's laid out here. There's a section where you can read about it. So oxidation state, talking about assigning numbers to very specific elements. So for instance, oxides, oxygen, when it's the most electronegative atom in a compound, will be -2. Hydrogens are typically +1. There's exceptions when there's peroxides or hydrides and so forth. That is the way you've learned it before. That's typically the memorization approach. This presents a second way of doing it, looking at the electronegativity of atoms within bonds and making decisions which is more and which is less, assigning numbers, and then getting an overall oxidation state for each of the atoms. It might be a little unfamiliar at first, but it's an incredibly effective way, always gets the right answer, and if you learn to do it, you don't have to worry about memorizing exceptions. Right after that, notice there's a question. We are big on questions. Questions are built into the text, so I want you to do all the questions in the text. So the review portion, the text portion, if you decide not to read, that's perfectly fine, but use the questions as again, a learning tool. Rehash, get your content review through practice questions. You'll also notice on the left-hand side, right below where it says general chemistry, that open column about 2 inches wide, that's for note taking. Don't take a lot of notes, take minimal notes, but the big thing we really want you to do is if you see an idea that's really good or a technique that's really good or some trick or some idea you have, even if you're integrating something you learned before that you want to add in, write it in there. Keep in mind these books are workbooks. They're meant to be written in. They're not textbooks. Don't treat them as pristine. You're not going to sell them back to the bookstore at the end. You're going to use them. Get utility out of them. Write in them. As you go through the books, keep an ongoing list of the things that are helpful. Little strategies, little tricks, little techniques. I've tried to put in about 8 to 10 really useful tips and unique ways of doing a lot of these questions, applying the information. Pay attention to it. Like when you get R and S in stereochemistry, I believe the way that's listed is a more effective way that can get every structure. If you like it, write it down in the margin. Be able to reference it later. Okay, after you do the review portion, it's time to start doing homework. Homework phase 1, it's listed there. You can read through it. The suggestion is do it 3 times. First time you do it in pencil or black ink. Write all your thoughts down. Write what you are doing on that passage, on that question, because you want to grade not just whether you got the answer right or wrong, but more so, did you go about the right pathway to get there? So look at how you answer the question and evaluate what steps were good, what steps need to be modified. Grade it 1 time. Just look at the answer letters, mark right and wrong using blue ink. Any questions you got wrong, try them again. Let's say you picked choice A, you know it's not A, so now decide between B, C, and D. Write your thought process in blue this time. Then when you're done, go to the back, grade it, but when you grade it, read the answer explanation and go back in red ink and write yourself a note what you could have and should have done differently on the various questions. That way you've color coordinated where you're at. If it's a lot of pencil, you know this topic really well. If it's a lot of blue ink, you know the material, but you might have not read the questions well, or you might need to work on test skills. If it's a lot of red, then maybe you need to go back and read the chapter, get the content down pat. But use phase 1 as an evaluation of where you're at. Key things on phase 1, you do not worry about timing. Just don't worry, concern yourself. It's more important to get good test habits, good test skills down pat. That's what you're doing phase 1 for. Content review and then getting into good habits. You'll notice, number 1, the passage. This is an organic chemistry passage. A lot of what they'll do is they'll give you typical biomolecules, like in this case, it's a pathway you're familiar with, and then they'll ask you OChem questions about those structures. So it's really OChem questions applied to bio-related organic molecules. Notice the first couple of questions. What are the oxidation states? What's a reducing agent or what is not a reducing agent? These are skills that you just have to know. This is, again, emphasizing a little more content, a little more straightforward information. These are not as Mcat realistic as the ones later in our book. These are meant to just get you the information, the foundation. This is content review. Last but not least, learn from your answer explanations. You're going to learn far more going over the answers than you will from any other part of your studies. So the best learning is learning after you've thought about it, active learning. Timing is everything. Try to do phase 1 as quickly as you can after the reading. Try to hone it in or treat it as a more important thing. Maybe start with phase 1 and go back and read what you need. But make that one sitting. Okay, after you've done phase 1 comes phase 2. You have the information down, you have the content down. Now it's time to start working on test skills. That would include timing. Timing is of the essence. Lots of people know their stuff really well, but if you don't know it well fast enough, you can get in trouble on the test. So this one, you are going to worry about timing. In the chemistry, the general chemistry and physics books, I should say, there's going to be 25 questions for phase 2, takes 35 minutes. For the organic chemistry book, there's 50 questions, it's going to take 70 minutes. They're time consuming, but do them in one sitting and definitely pay attention to your time. Finish everything on time that you can. If you go overtime, mark how much you go overtime. I've intentionally set it up to be kind of tough. So for instance, let me show you an example of a page. In this page, you'll notice that the passage is much longer than what you encountered in phase 1. And there's a lot more information. So what it is this case, it's flow. So they have 3 equations on flow rate, one dealing with the actual speed of the molecules compared to the cross-sectional area of the pipe. Another one, Poiseuille's law of volume flow rate, which you may have learned in both physics and physiology. And the last one, Reynolds number, which says how streamlined, i.e. laminar, or how turbulent, chaotic the flow is. And then they loosely tie it to blood flow. So it's kind of physiology, kind of physics. It's the mixture of the two. Physioics is very, very important on the Mcat. Okay, for this one, again, keep track of your timing, be quick. Do not read sentences twice. Do not over-process the passage. Get the bare minimum out of it, start doing questions, and if there's something you needed from the passage you didn't read thoroughly enough, you're going to go back and fish anyway. One of the biggest mistakes people make is they try to thoroughly outline and analyze and process the passage, and there's lots of information in the passage, maybe up to half of it, that you're never going to be asked about. They put things in the passage, I think, just to freak people out, or just because they're lazy and they don't edit it down to make it specific to the questions. There's always more stuff in the passage than what you actually need. Don't overanalyze the passage. This is something you have to learn through phase 2. Okay? Focus on your test-taking skills. That's absolutely imperative. So process elimination, POE, definitely the biggest one most of us use. But there's other things you may not even realize you use. You might do the zero-in method, where you zero in on a right answer by knowing what's right, find that answer, and then evaluate that. And if it's good, you go with it. If it's not, then you look at where that information zero in on a second answer choice. Whatever your technique is, be very cognizant of it. So one thing that students realize, and it takes a while, is that when a question seems easy, it's because they have in their mind a mental algorithm that they follow, they flow through, they get a right answer. Be very aware. When you do something subconsciously, you just pick a right answer, stop, figure out what you did, write it down, get this flow chart, and then on really hard questions, see if the flow chart that you just instinctively do on easy questions helps on hard questions. And you'll be really surprised to figure out that it does. Learning what you do on simple questions is the first step to being able to simplify the more complicated questions. So again, you're grading not your content knowledge, not your score, you're grading your ability to get a right answer. Every single time you go through answer explanations, ask yourself, could I do this question 15 seconds faster? And could I get the answer more cleanly if I ever saw this again? If the answer is yes, perfect. That's why scores on homework, they're useless. They don't mean anything. If you get 56% on phase 1, which was what the average student gets, perfect. You're learning from your mistakes. You're going to go on to get about a 510 to 512 on the Mcat. If you're getting 62% on phase 2, again, you're perfect. You're right where you're supposed to be. I write questions that people miss on purpose because you learn more from answer explanations than you do anywhere else. So the best way for me to make sure you're reading the answer explanations, put a cumbersome question, put a convoluted question in there, that even if you might get it right, you're probably still going to read through the answer explanation. Our answer explanations, if you look at the thickness of the books, and I'm sure you freaked out when you first got them, the bulk of our books, easily half our books, are answer explanations. That's where you do your real learning. Don't panic that they're thick. Be grateful that the answer explanations are going to be as helpful as they are. Finally, the last phase, phase 3, this is where you're putting it all together. These are our most Mcat realistic, Mcat-esque passages of all. You'll notice a lot of them are on experiments. They're on a machine you may use in lab. They're typical of what the AAMC throws in their actual passages. And so, for instance, let me go ahead and look at this. Homework phase 3. This passage, although it's taken from general chemistry, if you look carefully at it, it's got part physics in it. And that's exactly what they do. They integrate different concepts. And so in OChem books, phase 3 is labeled phase 3. It follows phase 2. It's right after the chapter. It's where you expect it to be. For JChem and physics, I've done something a little bit different. So a few years back in the making of the books, I decided to integrate it into a practice test in the back of the book. So phase 3 is a bunch of practice tests at the end. So if you go to chapter 1, you turn through it, there's a phase 1 homework, phase 2 homework. All of a sudden it just goes to chapter 2 right after that. That's because phase 3 is actually listed in the back of the book as practice test 1.1, meaning book 1, section 1. Phase 3 of chapter 2 is 1.2. Phase 3 homework of chapter 3 is 1.3, and so on. And what they do is they incorporate material from the entire book. The majority of the questions will be associated with the chapter that it's associated with, but there's plenty of questions from other topics, plenty of integrated questions, so that way you don't get tunnel vision. Sometimes on phase 1 and phase 2, let's say it's about acid-base chemistry, your mind is focused on acid-base chemistry, so you can do well in it. On the Mcat, you don't know what the passages are about, and oftentimes there are multiple topics. That's what this phase of the homework emphasizes. So for instance, we just look at this passage, you'll note it's got burettes, so it's got some titration involved. It's got a circuit, so there's some current involved. And then in the table you look at the amperage, which corresponds to how soluble the salt is, or what ions you get in solution or don't get in solution, as it may be, which means there's some solubility in it. So this is a passage that includes titration, circuits, and solubility, which means if you have run into something like this on the Mcat, you have 5 or 6 questions, they can only do at most 2 on any of those individual topics. So it's going to have a couple quick titration questions, a couple of circuit questions, maybe a solubility question. You need to get used to your thinking about multiple subjects and how they tie together. A couple things. Focus on getting as much as you can out of the passage very quickly. So if you came across this, the reading might be useful, especially for details, like what the concentration is, how many milliliters you were using, what sequence was added in. But the most important part of it is usually in the picture. From the picture and the table, look at the trend in the data, look at how the apparatus is set up. A lot of times you can deduce what's going on without actually reading it. You can just get an understanding of the experiment from familiarity with the equipment, but also realizing that if it's a circuit, if it's burettes, there's a little bit of titration, there's a little bit of circuitry. Reverse engineer every question. What I mean by this, don't just look at what the right answer is. More importantly, look at the wrong answers and why they're there. Are they a wrong answer based on a careless mistake? Are they a wrong answer based on, let's say, a negative sign? Are they a wrong answer that was from something in the passage but it's irrelevant? Is it a true statement but it doesn't answer anything? The reason you want to do this is the more you can figure out what type of wrong answers they write, the better you'll be at zeroing in on a right answer and getting rid of wrong answers. It's a whole concept that if you ever TA'd or tutored, you learn the material so much better because now you have to teach it. You're looking at it from a different perspective. I'm sure any of you who've TA'd or tutored, you've found this. If you ever had to write a practice test, you discover how people write tests. And if you're better at test writing, you become better at test taking. You'll get all those skills honed in. So last but not least, as you work through phase 3s, craft a summary sheet, not too long, just a short one, of the tricks and strategies. So you might have found like our lens and mirror technique. You won't read about this anywhere else in the world. It's just a really cool technique specific for Mcat style multiple choice questions. It's a targeted technique. You want to put it down on a piece of paper and review it before you do a practice test, because if you get one on the test, you'll be able to get through it in 15 seconds or less, when most people might take over a minute. You're going to get it right with no careless errors. They might miss it. So the whole idea is hone in the cool little tips and strategies and techniques that we toss in there. So that's the layout of the books. That's how you get the most out of them. The big thing is schedule time to do everything. Make sure you do all the phase 1, phase 2, and phase 3. And I mean, you read stories on Reddit about people who studied like crazy and they didn't do well. You look at Student Doctor Network and somebody says, I don't get it. I went through this set of videos. I read all this in this commercially available book. I felt really good, and I got a 3, or let's say the best I did was 3 points below average. Let's say I ended with like a 492, something like that. It's just It's just the fact that they don't do enough questions. Learn from what you've done. We've collected questions over the years. I always am updating the books based on feedback. For every one question you see, there's at least two or more that we threw away. That's because every question is targeted. Every question has a purpose. You're going to do great on this test. You're going to have some high moments and some low moments. Work your way through the low, ride the high as best you can. Enjoy this process. It's actually can be a lot of fun if you treat it the right way. If you have questions, I'd ask you, please reach out to our company. Email, um, contact us, and we'll get back in a fairly short amount of time. We're a small company. We're very grateful. Can't tell you how grateful we are that you've chosen our books to use them. Thank you for taking time to buy them. I mean, quite honestly, stolen books are the thing that'll if we end up out of business, and we've been pushed to the brink a lot of times, it really is because of that. So when you're honest and buy books, it ripples through. It allows everything to be better. We can make better materials. Um, and for some of you who've commented on Reddit and Student Target Network, I can't thank you enough. The positive comments, you don't really think about it, but honest truth is that all of us who write, all of us who have some purpose in this, we ghost it. We always look to see what the comments are. I do it every time I get ready to change the book. I'll read, because you get a lot of good feedback from students in class, but you also get a lot of good feedback reading comments on Student Doctor Network and Reddit about what generic users are like, people you actually don't meet, what they get from it. So we try to adapt. So thank you for all the positive comments. I mean, they make a difference. So thank you for taking the time to watch this video. Again, if you have questions, email us, and good luck on the test. You're going to do great. Just keep plugging away. Thank you.